Hello and welcome everybody to another episode of Books and Bytes.
Today we're diving into a really fascinating book.
Yeah.
Robert Hooke's Micrographia.
Micrographia.
Published way back in 1665.
1665, that's...
This book, I think it's fair to say, revolutionized how we see the world.
It's interesting because, I think of micrographia and I just think tiny things.
Right.
I think of, the fold-out engravings of like a flea and different insects and things like that.
But there's so much more to it.
So it's more than just a collection of, kind of cool pictures of tiny things.
Exactly.
Right.
It's groundbreaking work that explores, I would say, three major things: the power of observation, the limitations of our senses, and the importance of using instruments to expand our understanding of the natural world.
I like that. So it's about more than just tiny things seen through a new lens.
It really is.
Okay.
Hooke uses his microscope to reveal a universe of detail that we normally miss. But he also uses those observations to argue for a new way of thinking about science.
Okay.
A method based on observation experimentation and challenging our assumptions.
I mean, that's still how we do science today.
Absolutely.
Okay. Well, I'm already intrigued. I was a little bit apprehensive, but I'm intrigued now.
Good.
So give us the lay of the land. What kinds of things are we going to encounter in this book?
Well, Hooke takes us on a journey through a vast array of subjects.
Oh, wow.
Needles, fabrics, glass fire, plants, insects, even light and color.
Wow, so the whole gamut.
That's
a lot to cover.
He covers a lot of ground.
Okay.
He reveals this world of intricate structures and hidden processes and really challenges us to reconsider what we think we know about the world around us.
Okay, I'm ready to have my mind blown.
Great.
Let's start at the beginning.
Okay, so right from the start, Hooke makes this really passionate case for the importance of observation.
Okay.
He argues that our senses are limited and that we often rely too heavily on reason and memory, which can lead to errors.
So he's saying we can't always trust what we think we see.
Exactly.
Yeah.
He even uses this brilliant analogy.
Yeah.
He says, as seamen do their dead reckonings by celestial observations, so must we correct our hypotheses by sense.
So basically he's saying we need to double check things.
Yeah.
If you're sailing across the ocean.
Right.
And you're just using dead reckoning.
You can end up way off course.
You're going to end up in the wrong place. And so
precisely,
you have to check.
You need to use the stars.
Use the stars. Use your instruments to confirm what you think is true.
Yeah, and that's a really powerful image.
Yeah.
It emphasizes the importance of challenging our assumptions.
I think it's something we all need to be reminded of today.
Yeah.
In the age of misinformation and...
Absolutely. It's so easy to get caught up in our own biases, our own preconceived notions.
Yeah.
But Hooke is reminding us to always go back to the evidence, to what we can observe, and to be willing to adjust our thinking based on that evidence.
Okay, so I like this idea that he's advocating for this approach to understanding the world that's very much based in observation and challenging assumptions.
Right.
And obviously for Hooke, the tool for doing that was the microscope.
Of course.
So let's talk about this microscope for a second.
Yeah.
I mean, what kind of contraction are we talking about here?
Right. So imagine a world before electricity where even a magnifying glass was a cutting-edge tool.
Right.
Hooke's microscope was a simple compound microscope.
Yeah.
Much less powerful than what we have today.
Right.
He even describes making some microscopes from tiny glass threads.
Glass threads. I mean, that's just incredible.
I know.
The level of craftsmanship that must have been involved.
Right. And the patience.
Oh, yeah.
Right. To grind those lenses, to get them just right.
And the lighting. I mean, how do you even light something like that?
It was a real challenge.
Yeah.
But he did it, and he made groundbreaking observations with it.
Yeah. I mean, that's really remarkable.
Yeah.
Okay, so I'm curious now. What was the first thing that Hooke turned this microscope on?
One of the first things he examined was a needle.
A needle.
Now we look at a needle, and we think sharp, smooth, simple, right?
Yeah.
But Hooke's microscope revealed a completely different picture.
Don't tell me it was covered in tiny monsters.
No monsters.
Okay, good.
It's not quite science fiction.
Okay.
But think of it more like a rugged mountain range.
Okay.
He describes the surface of the needle as being incredibly rough and uneven.
So something that we experience as perfectly smooth
is
actually
jagged and rough.
At the microscopic level.
Yeah, exactly.
It's kind of blowing my mind a little bit here.
I know, it changes how you think about the world.
Yeah.
And that was exactly the kind of shift in perception that Hooke wanted to achieve.
Okay.
He was showing that our senses can deceive us, and that there's this hidden world of complexity beneath the surface of even the most everyday objects.
Okay, so he starts by shattering our assumptions about needles.
Right out of the gate.
What did he turn his attention to next?
Well, from needles,
Okay.
he moved on to another seemingly smooth object.
Uh-huh.
The edge of a razor.
The edge of a razor.
And again, his microscope revealed this world of unexpected texture.
Okay.
He describes the razor's edge as being full of notches and irregularities.
Okay.
Further emphasizing his point that our perception of smoothness is often an illusion.
So it's like he was really trying to wake people up to the idea that what they thought they knew was not necessarily the whole story.
Exactly. He wanted to shake us out of our complacency and make us really question what we think we know.
Yeah, and I can imagine that being pretty radical.
He was. For the 17th century,
yeah,
this was mind-blowing stuff.
Yeah.
He wanted people to understand that there's this vast universe of detail hidden from our unaided senses. And by revealing this hidden world, he hoped to inspire a new spirit of scientific inquiry.
I love that.
Yeah.
Okay, so we've got rough needles and jagged razors.
Right.
What other seemingly smooth object did he debunk?
Well, from there, he turned his attention to textiles.
Textiles, okay.
And what's fascinating here is that he didn't just observe, he compared.
Okay.
He looked at both silk and linen.
Okay.
And noted the striking differences between their structures under the microscope.
So he wasn't just passively looking, he was actively analyzing what he saw.
Exactly.
Okay.
He describes silk fibers as being round, smooth, and transparent.
Okay.
While flax fibers, which make linen, were flat, rougher, and less transparent.
Interesting.
And he didn't stop there. He connected these observations to the properties of the fabrics themselves.
Oh, so he was drawing a connection between what he was seeing in the microscope and how those materials actually behaved in the real world.
Exactly.
That's pretty insightful for the 17th century.
He explains, for example, that the smoothness and roundness of silk fibers is what gives silk its unique luster and drape, while the rougher, flatter structure of flax fibers makes linen feel stiffer and less lustrous.
So he's uncovering the secret code of fabrics.
He is.
Showing us how their microscopic structure determines their qualities.
It's like he's giving us this new language for understanding materials.
I like that.
Yeah.
What did he examine after textiles?
Well, from the seemingly mundane world of fabrics, Hooke takes us to something much more dramatic.
Okay, I like where this is going.
Glass drops.
Ooh, glass drops. Those
teardrop-shaped pieces of glass that explode when you snap off the tail.
I've always been fascinated by those.
I know, they're amazing.
Yeah.
And Hooke was captivated by them, too.
Okay.
He meticulously studied how they break, theorizing that the explosive shattering was caused by internal stresses within the glass itself.
So he was digging into the physics of glass, trying to understand what forces are at play.
Absolutely.
Wow.
And what's remarkable is that his ideas about these internal stresses are still relevant to how we understand glass today.
Wow, he was way ahead of his time.
He was.
It seems like Hooke had this uncanny ability to see beyond the surface of things, to understand the hidden mechanisms driving what we observe.
And that's what makes micrographia so groundbreaking.
Okay.
It's not just about the observations themselves, but about the way he uses those observations to reveal the deeper principles governing the natural world.
I like it.
Yeah.
Okay, so we've explored rough needles.
Right.
Uneven razors.
Yes.
The microscopic secrets of silk.
Mm-hmm.
And the explosive nature of glass drops.
It's been quite a journey already.
What other wonders did Hooke uncover in the microscopic realm?
Well, next he turns his attention to something truly fundamental: fire.
Okay, before we dive into the flames,
let's
take a moment to reflect on what we've learned so far.
Sound good.
And then we'll come back and we'll jump into Hooke's investigation of fire, combustion, and the very air we breathe.
I'm looking forward to it. Welcome back.
So we left off talking about fire.
Yeah.
Okay, so how does a 17th century scientist approach something as elusive as fire?
Well, remember, this is a time when people are still debating the very nature of fire.
Right.
Some thought it was an element, others a substance.
Right. Fire, water, earth, and air.
Exactly, the 4 elements.
Yeah.
But Hooke was determined to understand it.
Yeah.
Not through these abstract theories,
Okay.
but through observation and experimentation.
So he turned up the heat literally and started looking closely.
Precisely. He describes his experiments with burning candles.
Yeah.
Pieces of wood focusing on how the flame behaves.
Okay.
How it consumes the fuel, and crucially the role of air in the process.
The role of air, I'm guessing that wasn't so obvious back then.
You know, it might seem obvious to us now,
Right.
but in Hooke's time, the idea that air was essential for combustion was revolutionary.
Really?
He was one of the first to actually demonstrate this through experiments.
That's fascinating.
Yeah.
So how did he prove that air was involved?
Well, he designed this detailed method for constructing a mercury barometer,
Okay.
a device for measuring air pressure.
Okay.
And then he used this barometer to study how heating air causes it to expand,
Okay.
linking that expansion directly to the process of combustion.
Wait, hold on. He built a barometer to study fire. That's some serious interdisciplinary thinking for the 17th century.
It is. He wasn't content with simply observing the flames. He wanted to understand the underlying forces at play.
Yeah.
And by connecting his observations of fire to his experiments with air pressure,
Right.
he was able to show that air is a critical component of combustion.
So he was connecting physics and chemistry.
Yeah.
Centuries before those fields were even really formally defined.
Exactly.
That's amazing. Okay, so after revealing the secrets of fire,
Right.
where did Hooke's microscopic journey take him next?
Well, from the intensity of fire,
Yeah.
he turns his attention to something much more delicate and intricate, the world of plants.
Yeah.
And here we really see his observational skills and his artistic talent on full display.
I'm imagining beautiful drawings of flowers and leaves under the microscope.
You're not far off.
Okay.
But Hooke goes beyond simply capturing the beauty of plants.
Okay.
He really dives into their structure,
Okay.
dissecting and examining everything from cork cells to charcoal to the tiny hairs on nettles.
Cork cells. Is that where the term cell comes from in biology?
It is.
Get out.
Hooke was the first to use the term cell to describe the tiny compartments he observed in cork under his microscope.
Wow.
He was struck by their regular box-like shape,
Yeah.
resembling the small rooms or cells found in monasteries.
Right.
And while he didn't fully grasp the biological significance of cells at the time,
Right.
his observation was a monumental step towards understanding the building blocks of life.
So he coined one of the most fundamental terms in biology while looking at a piece of cork.
Pretty amazing, isn't it?
That's wild. What else captivated him in the plant world?
Well, he was particularly fascinated by what he called humble plants.
Oh.
These included mosses,
Okay.
which he meticulously drew,
Yeah.
capturing their intricate structure with incredible detail.
It's like he found beauty and wonder in the most unexpected places.
He did, and that sense of wonder extended to his observations of seaweed.
Seaweed, okay.
He described one type as a most curious kind of carved work, marveling at these tiny holes,
Yeah.
arranged in a precise and delicate order.
It sounds beautiful.
It is.
He was a true observer of nature,
He was.
finding intricate patterns and beauty in everything from a simple piece of cork
Right.
to delicate seaweed.
And that's one of the lasting legacies of micrographia.
Okay.
It encourages us to look closer, to appreciate the complexity and beauty that exists at all scales, even in the seemingly mundane.
Okay, so we've gone from the rough texture of a needle
Right.
to the intricate structure of a plant.
Yeah.
Where does Hooke take us next?
Well, now he ventures into a realm that continues to fascinate us today, the world of insects.
Okay, I'm ready for some close-ups of creepy crawlies. Let's dive into the world of bugs.
Let's do it.
Okay, so we're back, and I'm ready to delve into the world of insects with Robert Hooke and his trusty microscope.
Get ready to be amazed. Hooke's observations of insects are incredibly detailed and really showcase his ability to connect structure to function.
Okay, so what kind of bugs did Hooke put under his microscope?
Well, he examined a wide variety of insects, but some of his most captivating observations focus on flies, bees, and ants.
Those are some of my favorites, too, especially when they're magnified hundreds of times, I bet.
You know, for example, he was fascinated by the compound eyes of flies.
Those multifaceted eyes that kind of look like honeycombs.
Precisely. Remember, this is a time when the very idea of multiple lenses working together was mind-boggling.
Right.
Hooke meticulously describes the structure of the fly's eye, noting its arrangement of tiny lenses, and even speculating on how this structure allows the fly to see such a wide field of view.
So he was trying to understand not just what it looked like, but how it actually worked.
Yeah. He was a pioneer in exploring how different creatures perceive the world.
That's incredible. So from the complexity of a fly's eye, where did his observations take him?
Well, he doesn't shy away from the less pleasant aspects of the insect world either. He dedicates a whole observation to the sting of a bee.
Ouch. I bet that was a bit painful, even under a microscope.
He calls it a weapon of offense, and he describes it having a sheath and a sharp dart, and of course, the venom.
Yeah, the venom is what gets you.
He even compares the sting to a pistol.
A pistol, wow. Talk about vivid imagery.
He describes the tiny barbs on the sting, noting how they're shaped like cat's claws, which helps inject the venom.
So he's a scientist, but he's also a bit of a poet.
He's a storyteller, really. He's helping us visualize these tiny, often overlooked details.
So we've got flies with their multifaceted eyes and bees with their weaponized stingers. What other insect adventures did Hooke take us on?
He also spent a lot of time studying ants. And this is where his patience and meticulousness really shine through.
Okay.
He dissects an ant, painstakingly describing its legs, mandibles, even its internal organs.
Dissecting an ant. I can't even imagine trying to do that.
It must have been a challenge. But Hooke's attention to detail is remarkable.
Yeah.
And his descriptions really showcase the ant's complexity and elegance.
I think that's a recurring theme here. It's like he's not just observing these creatures, he's marveling at them.
He is. And his observations really challenge people to see these creatures not just as pests, but as fascinating beings with their own complex lives and adaptations.
It's like he's opening up a whole new world to us.
Right.
So we've explored the realm of plants and the intricate world of insects. What other hidden wonders did Hooke reveal in Micrographia?
He also turned his microscope on a variety of other natural phenomena. He examined snowflakes, frost patterns, marveling at their intricate, often symmetrical forms.
That's interesting because even with a simple magnifying glass, snowflakes are beautiful.
Right, they are. He describes them as six-cornered stars, and he points out that no two are alike.
So he's finding beauty and wonder in something as common as a snowflake.
Exactly. He had this uncanny ability to find beauty and complexity in the seemingly mundane.
And this is just one guy with a very basic microscope.
And it speaks to the power of curiosity and meticulous observation.
I think so.
Hooke's work reminds us that there's always more to discover, even in the most familiar things, if we take the time to look closely.
That's a great reminder, I think. So after this incredible journey through the world of micrographia, what's the big takeaway?
Well, Hooke's legacy is immense.
I imagine it is.
He was a pioneer in microscopy, optics, and experimental science. And Micrographia wasn't just a popular book. It was a turning point in scientific thought.
Yeah.
It helped usher in a new era of observation and experimentation, paving the way for future scientists like Isaac Newton.
He kind of gave us a new way of seeing, both literally and figuratively.
Exactly. And his work continues to inspire us today. After this deep dive into Micrographia, it's hard not to look at the world around us with a renewed sense of wonder.
That's very well said. And for those of you who are feeling inspired to explore further, you can check out Micrographia for yourself. It's freely available online.
Yeah, thanks to Project Gutenberg.
That's a great resource. And for all of you out there, until next time, keep exploring, keep questioning, and keep looking closely at the world around you.